Welcome to Study Session with the Data Lord. We're going to blockchain and chill. We're just going to hang out. We're going to read some white papers and discuss some concepts, see if we can't learn some things. We are currently studying Cosmos. Cosmos is a really big ecosystem cryptocurrency. So you can build applications on top of Cosmos, and a lot of people have. That whole Binance company, they've built on Cosmos. So, this is big leagues, and we're just gonna walk through it, see what we can do. I did want to say real quick that I know for me, it can be challenging to sit in the quiet by myself and just read white papers. I have to kind of have some music on, have some, like tea or something that I'm into drinking, and just kind of make a ritual of it where I'm chilling and I'm just going through it, and it's kind of a mood. So I'm hoping to bring you into that, and you can have a friend, me, the Data Lord, take you through the study session, and I hope you get some out of this. And if you have any suggestions or questions, I'd love to see them in the comments here. I do monitor my YouTube for comments, so let's get stuck in. Last session we went through the introduction, which surprisingly took an hour. We had a lot of exploring to do with some of the concepts and tools that it brought up, but we're in basics, so let's get into it. So in basics, we're going to go over the anatomy of a Cosmos SDK application. That's sweet. We're going to hit transaction lifecycle, also dope. We're going to look through query lifecycle, accounts, and gas fees. Okay, cool. Let's do it. So, application of a Cosmos SDK. Anatomy of a Cosmos SDK application. So this document describes the core part of a Cosmos SDK application. Throughout the document, a placeholder application called app will be used. So any place we see this lowercase app, that means that's referencing the placeholder application. So yeah, that looks better. So node client. The daemon or full node client is the core process of a Cosmos SDK based blockchain. Participants in the network run this process to initialize their state machine, connect with other full nodes, and update their state machine as new blocks come in. Okay, so we have let's go through that and compare it to the graphic down here. So this is the daemon, which is a full node client. So I think this whole thing is the daemon or full node. It's the core process of the Cosmos SDK based blockchain. Participants in the network run this process to initialize their state machine. Okay. Yeah, I think that's what this is. So we have a state machine equals application. The application blockchain interface does input and output to consensus. And then there's a network layer. And built with Cosmos SDK, and then Tendermint core. Okay, I think it works from the bottom up, actually. It's okay. So the blockchain full node presents itself as a binary, generally suffixed by -d for daemon. An example, appd for app, or Gaia D for Gaia. This binary is built by running a simple main.go function placed in the root/cmd/appd This operation usually happens through the make file. Okay, makes sense. Once the main binary is built, the node can be started by running the start command. This command function properly does three things. It, number one, creates an instance of the state machine defined in app.go. Number two, it initializes the state machine with the latest known state extracted from the DB store in root.app/data folder. At this point, the state machine is at height app block height. Okay. And then three, it creates a new, create and start a new Tendermint instance. Among other things, the node will perform a handshake with its peers. It will get the latest block height from them and replay blocks to sync to this height if it is greater than the local app block height. Okay. If app block height is 0, the node is starting from Genesis, and Tendermint sends a init chain message to the application blockchain interface to the app.go, which triggers the init chainer. Okay, I think I'm kind of hanging with this. Let's review that before we go on. I don't want to just breeze through it and have core concepts missed, right? So it looks like, what are we doing here? So the blockchain full node presents itself as a binary, okay? So the generally suffixed by -d for daemon. So I get that. So if there's like a daemon, which daemons are like an instance, right? So if we look this up, daemon in computing. So in multitask computing or computer operating systems, let me restart that. In multitasking computer operating systems, a daemon is a computer program that runs as a background process rather than being under the direct control of an interactive user. Traditionally, the process names of daemon end with the letter D for clarification that the process is in fact a daemon. And for differentiation between a daemon and a normal computer program, for example, syslogd is a daemon that implements system logging facilities, and SSHD is a daemon that serves incoming SSH connections. Cool. Yeah, so daemon just means a program that's kind of running in the background and serving as a background process. So the background full node, the blockchain full node presents itself as a binary, generally suffixed by -d for daemon. So these are just background processes that are running that provide a service, right? Binary is built by running a simple main.go function. Okay, so we basically have a daemon, and we create a binary config for main.go. This operation usually happens through a make file, right? And it looks like they have a specific way their make files work. So a patch introduced in Go-gRPC 1.34.0 made gRPC incompatible with the Go proto, like that word, library, making some gRPC queries panic. As such, the Cosmos SDK requires version 33.2. 1.33.2 is installed in your Go mod. So to make sure that the gRPC is working properly, it is highly recommended to add the following line in your application's go.mod. I see. Yeah, so a make file is just all the instructions to build your binary. So all right, cool. So once the main binary is built, so it builds it from scratch, makes it look right according to whatever instructions are there. And that way you can keep iterating and adding things to your application and just spin up a new instance. This binary is built by running a simple main.go function, blah, blah, blah. Once the main binary is built, the node can be started by running start command. Yeah, so we build the binary and we start it. And it does three things. It makes an instance of the state machine. It initializes that state machine with the latest known state extracted from the DB store. Okay, cool, I get that. At this point, the state machine is at height, app block height. And then create and start a new Tendermint instance. Among other things, the node will perform a handshake with its peers, and we get the latest block height from them, and replay blocks to sync to the height if it is greater than the local app block height. If app block height is 0, the node starting from Genesis and Tendermint sends the init chain via the application blockchain interface to app, which triggers the init chainer. Okay, sick. Totally. I'm hanging with this now. So basically, we give instructions to build our app however we need it to be built, and then once we have those instructions, we run the binary, and then what it will do is it's literally grabbing like wherever the blockchain left off at, and then if it tries to grab it and it's nothing, it has to start the Genesis block, which is 0, and then it starts your blockchain from that point on, right? So that's the my understanding of what we just read, broken down into some more simple language. So core application file. In general, the core of the state machine is defined in a file called app.go. It mainly contains the type definition of the application and functions to create and initialize it. Okay. Core of the state machine is defined in app.go. Mainly contains the type definition of the application and functions to create and initialize the application. Okay. So it's more config for the application. So type definition of the application. First thing defined in app.go is the type of application. It is generally comprised of the following parts: a reference to the base app. The custom application defined in app.go is an extension of base app, and when a transaction is relayed by Tendermint to the application, app uses base app's method to route them to the appropriate module. Base app implements most of the core logic for the application, including all of the application blockchain interface methods and routing logic. Okay, so a reference to the base app. The custom application defined in app.go is an extension of base app. Okay, so app.go will work off of base app, and it will build on it with whatever is different. And then when a transaction is relayed by Tendermint, which is like the networking layer of the consensus mechanism, to the application, app uses base app's method to route them to the appropriate module. So then that's the piece we were talking about last session, where it can send it, specifically to governance or whatever other module is there. Yeah. Routes them to the appropriate module. Base app implements most of the core logic for the application. So almost everything is in base app, it looks like, including all the application blockchain methods and routing logic. Okay. So basically most of the things that we need are always going to be in base app. They've set it up to be pretty full featured, and all we're doing for our custom apps is just adding one-off pieces to that picture. So I'll a list of store keys. So the store, which contains the entire state, is implemented as a multi-store. Which is like a store of stores, like a mall. Okay. In the Cosmos SDK, each module uses one or multiple stores in the multi-store to persist their part of the state. These stores can be accessed with specific keys that are declared in the app type. These keys, along with the keepers, are at the heart of the object capabilities model of the Cosmos SDK. Okay, so let's read that again. A list of store keys. So the store, which contains the entire state, is implemented as a multi-store. A store of stores in the Cosmos SDK. Each module uses one or multiple stores in the multi-store to persist their state. Okay, so basically we can store the value of a lot of different states in that multi-store. So we can like every value that could be configured basically has a state that it can store in that multi-store, is my understanding. These stores can be accessed with specific keys that are declared in the app type. So not anyone or anything can access them. They're locked behind keys, but the values are there. These keys, along with the keepers, are at the heart of the object capability model of the Cosmos SDK. Okay, so it's got security, but all the data is there. It's just worthless unless you have a key to unencrypt it, right? Or decrypt it. Cool. A list of modules keepers. Interesting. Each module defines an abstraction called keeper, which handles reads and writes for the module store. The keeper's methods of one module can be called from the other module if it's authorized, which is why they are declared in the application's type and exported as interfaces to other modules so that the latter can only access the authorized functions. I'll read that again. I usually have to read things like 2 or 3 times, and then my brain starts to kind of put the pieces together. So maybe you're that way too. So a list of modules keepers. So it stores, each module defines an abstraction called a keeper. So a keeper is an abstraction, which is like a reference, right? Which handles read and writes for the multi-store. The keeper's methods of one module can be called from other modules if it's authorized. Okay. So basically they can play nice together if your permissions are set that way, which is why they are declared in the application's type and exported as interfaces to other modules so that the latter can only access the authorized functions. So that sounds like it's like read and write permissions, and you can basically have different types of permission roles, is how I'm understanding that. A reference to an app codec. This application's app codec is used to serialize and deserialize data structures in order to store them, as stores can only persist in bytes. The default code is protocol buffers. Okay, let's understand that. So, a reference to an app codec. The application's app codec is used to serialize and deserialize data structures in order to store them, as stores can only persist in bytes. So, basically the data has to be, deserialized or serialized. So serial just means like ones and zeros, as opposed to deserialized as like hex values, right? So all this is doing is saying like, yeah, we can store it in hex values. I don't know if it's hex values. It's probably hex values though. We can store it in hex values, turn it into a serial data stream in order to move it from storage to, network packets is how I'm understanding that. Cool. A reference to a legacy amino codec. Some parts of the Cosmos SDK are not or have not been migrated to the app codec above and are still hard-coded to use amino. So they didn't define what amino is. Let's take a look. What's legacy amino? Okay. So the Cosmos SDK utilizes two binary wire encoding protocols. Amino, which is an object encoding specification, and protocol buffers, a subset of Proto 3 with an extension for interface support. Due to Amino having significant performance drawbacks, being reflection-based and not having a meaningful cross-language client support, protocol buffers, specifically GoGo Protobuf, that's nice, GoGo Protobuf, I love that, is being used in place of Amino. Note this process of using protocol buffers over Amino is still an ongoing process. So binary wire encoding of types in the Cosmos SDK can be broken down into two main categories: client encoding and store encoding. I think that's store encoding is the deserialized, where it's storing it in bytes. And then client encoding, I think, is when it's serializing it. Client encoding mainly revolves around transaction processing. Okay, cool. So client encoding mainly revolves around transaction processing and signing, whereas store encoding revolves around types used in the state machine, transitions, and what is ultimately stored in that Merkle tree, which is the blockchain. Interesting. So yeah, it looks like Amino is just the old way that Cosmos used to move things from storage to network to blockchain. So it was like just a protocol for moving things from different states. So okay, we can move on. So a reference to the legacy Amino codec. Some parts of the Cosmos SDK have not been migrated to use the app codec above. They're still hard-coded to use Amino, and that's so that they didn't break like a ton of applications they probably built, which relied on that being there. You see this in Linux a lot. People will build an application assuming that there's some package installed, and maybe it changes and the program breaks and nothing works right. And it works fine once you install those dependencies, but they're not like documented. So I've ran into that quite a few times just in my blockchain research so far. So other parts explicitly use Amino for backwards compatibility. Makes sense. For these reasons, the application still holds a reference to the legacy Amino codec. Please note, the Amino codec will be removed from the SDK in upcoming release. So they're giving people a warning shot before shooting to kill. Yikes. So a reference to a module manager and a basic module manager. The module manager is an object that contains a list of the application's module. It facilitates operations related to these modules. Like registering their MSG service, gRPC query service, or setting the order of execution between modules for various functions like initchainer, begin blocker, and end blocker. So let's read that again. A reference to a module manager and a basic module manager. Let's go down those trails and see what we find. Okay, so the manager is a structure that holds the app module of an application and defines the order of execution between several key components of these modules. Okay, cool. That's dope. Manager is a structure that holds all the app module of an application and defines the order of execution between several key components of these modules. So in this case, the order is, it starts that Genesis block, it exports the Genesis block, it begins blockers, end blockers, and orders migration. Okay, well, we're jumping ahead here, but that's cool. It's a basic manager. Basic manager is a structure that lists all the app modules of an application. It implements the following methods: new basic manager, construction function. It takes a list of the application's app module basic and builds a new basic manager. This function is generally called in the init to quickly initialize the independent elements of the application's modules. Yeah. Okay. So it looks like both of these managers they're defining order, and they're creating lists. All right, we'll back up. So, a reference to a module manager and basic module manager. And we know from our research that's just making lists and orders of operations. The whole PEMDAS thing you probably learned in algebra. And for anyone who's tripping because they can't remember what it stands for, it's parentheses, exponents, multiplication, division, addition, subtraction. So PEMDAS. Man, that sticks with you. That's great. Okay. So a reference to the manager or to the module manager and a basic module manager. The module manager is an object that contains a list of the application's module. It facilitates operations related to these modules, like registering their message service and their gRPC query service, or setting the order of execution between modules for various functions like init chainer, begin blocker, and end blocker. See an example of an application's type definition from SimApp, the Cosmos SDK's own app used for demo and testing purposes. Cool. So, inside of this simulation application, starts off with base app because we need that for everything. We have legacy amino because it's got to support old stuff. We have codec.legacy amino so that it can turn bytes into serial data streams. We have app codec, which I'm guessing is the new thing that replaces legacy amino, and codec.codec, which is replacing codec.legacy amino. We have an interface registry, which we haven't defined yet. Types of interface registry, haven't defined that yet. And then here's the keys. There's keys to access the substores. So, okay, yeah, I'm hanging with this. We have because remember up here we had this these keepers. They're acting just as kind of like permissions. So you can have different roles, and you can basically say like this one keeper can read and write here, but it can only read here. And it's just like if you had like in like an Active Directory type environment, you know, you could set it so that the like HR, let's say HR security group, like HR people can read and write to the HR folder, but they can only read IT because they don't own IT. But there's probably some like documents that are published in there that they have the right to read. So it's that idea, but inside the application. So keepers, we have account keeper, which is allowed. Let's see, account keeper. It has auth keeper and account keeper. Interesting. Bank keeper, tie keeper. Is there a pattern to this? Capability keeper, dot keeper. So these ones are, you know, the first word dot keeper. It looks like that's typically what they are. But this one here deviated. Account keeper is auth keeper dot, you know, the key pair. Interesting. But yeah, most of them are this value dot keeper. So NFT keeper. So the module manager, which is what MM stands for, I'm assuming. I think that's, you're defining shorthand. You're saying like if you type in MM, pull that up. Simulation manager, probably the same thing. You're creating a shorthand. So whenever you type in SM, it dumps that. That's my guess. Module configurator, module.configurator. Okay. Yeah, we got more questions than answers there, but that's okay. We'll keep moving. Constructor function. This function constructs a new application of the type defined in the section above. It must fulfill the app creator signature in order to be used in the start command of the application's daemon command. Okay, let's read that again. This function constructs a new application of the type defined in the section above. It must fulfill the app creator signature in order to be used in the start command of the application's daemon. Okay. So we have to like, it has to be signed basically in order to be seen as legitimate and work when we first start up that background service. That's my understanding and translation of that. So let's see. So app creator is a function. Oh, this is great. This is what we needed. App creator is a function that allows us to lazily initiate an application using various configurations. So app creator function, log.logger, database manager.db, io.writer, app, options, application. Okay, we'll keep going. Here are the main actions performed by this function. Instantiate a new codec and initialize the codec of each application's modules using the basic manager. Instantiate a new application with a reference to base app's instance, a codec, and all the appropriate store keys. Initiate, or I keep saying initiate, it's so funny. Instantiate all the keepers. And actually, I'm pretty sure that just means it creates an instance, but let's make sure we're defining. Yeah, it represents as or by an instance. Yeah, okay. It's just spinning up an instance. That's how like virtual machine guys would say it. So we're instantiating all the keepers defined in the application's type using the new keeper function of each of the application's modules. Note that the keepers must be instantiated in the correct order. Yeah, it makes sense. As the new keeper of one module might require a reference to another module's keeper. So basically, if they're not in the right order, you might miss a dependency, to build something else. So if you're referencing something that hasn't existed yet in that order of operations, then you have to fix it so that things exist as you're referencing them, right? So that makes sense. No big deal. It's kind of like you can't send an email until you create an email mailbox, right? If you send an email to like a new mailbox, but you haven't created that mailbox yet, it's gonna bounce back, right? You're like, well, I created the mailbox after. It's like, yeah, but like you gotta do that first, and then you can send a mail to it, right? Same thing. So this anatomy is kind of intense, man. Far down this go. Sheesh. Yeah, this is gonna be yowza. This is a session, friends and family. But we get explanations, so got our Sherlock Holmes hat on, There you go. Couldn't spell instantiate. Being a goofus. So all right, where'd we leave off? Instantiate all the keepers defined in the application type using the new keeper function of each of the application's modules. Note that the keepers must be instantiated in the correct order, as the new keeper of one module might require a reference to another module's keeper. So that's where we left off. Instantiate the application's module manager with the app module object of each of the application's modules. So with the module manager, initiate the application's message service, gRPC query services, legacy message routes, and legacy query routes when a transaction is relayed to the application by Tendermint via the application blockchain interface, is routed to the appropriate module's message service using the routes defined here. Likewise, when a gRPC query request is received by the application, it is routed to the appropriate module's gRPC query service using the gRPC routes defined here. Cosmos SDK still supports legacy message and legacy Tendermint queries, which are routed using respectively the legacy message routes and the legacy query routes. Okay, I totally hung with that. That's cool. Basically, it's saying that the module manager it initializes the application's message services, and then it can send data using these protocols. So that's pretty standard with most blockchains have an RPC, which you can do queries. You can be like, hey, how much if you check this wallet, how much money does it have in it? The RPC is the function that handles that, right? You can query that information on the blockchain. So has like a very practical use case of it, right? Like when you load up your wallet on Binance, for example, that kind of thing, it'll have an RPC call that goes to your actual crypto wallet and says, hey, how much money does this have? And it's like, yeah, that wallet has 400 Doge. What are you doing? What are you doing? Doge to the moon. So with the the module manager, register the application's modules invariants. Invariants are variables, so like total supply of a token, for example, that are evaluated at the end of each block. Cool. The process of checking invariants is done via a special module called the invariants registry. The value of the invariant should be equal to a predicted value defined in the module. Should the value be different than the predicted one, special logic defined in the invariant registry will be triggered. Usually, the chain is halted. This is useful to make sure no critical bug goes unnoticed and produces a long-lasting effects that'd be hard to fix it. Cool. With the module manager, set the order of execution between the init genesis, begin blocker, and end blocker functions of each application's modules. Note that not all modules implement these functions. Okay, so with the module manager, we can set the order of execution between the init genesis, which is where you first start the blockchain, begin blocker and end blocker, and we're defining them here, which is sick. We can set the remainder of the application's parameters. So init chainer, it keeps referencing, that's used to initialize the application when it is first started. So that just starts the app, right? Begin blocker and end blocker are called at the beginning and end of every block. So that's cool. It's basically begin blocker terminates the beginning of a block, and end blocker terminates the end of a block, and everything that's in between that is the information on that block of the blockchain, right? And then the anti-handler, which is used to handle fees and signature verification. So on most blockchains, the fee will basically pay to cut in line. So like the higher your fee is, the sooner your block will get processed, right? And so if this happens, like Ethereum was a good example when it was proof of work and we had a bunch of people freaking out buying a ton of like Bored Apes or something. People were like, yo, I need my transaction to go through. So people just kept paying a little bit more and a little bit more, and they hiked the price so high that it was just real expensive. It's like $50, $70 just to send, right? So that's stupid. But yeah, that's anti-handlers used to handle fees and signature verification. So it signs that. Mount the stores and return the application. So mount the stores, I'm assuming that's like once these blocks are signed, it has to store them in the history of the blockchain. And that's what the stores are doing. And then the return the application means start that over again. Let's validate a new block, right? So note that this function only creates an instance of the app, while the actual state is either carried over from the app.app/data folder if the node is restarted, or generated from the Genesis file if the node is started for the first time. Got it. So the actual state's either carried over from this app data folder, or if the node's restarted. Yeah, so if you reboot it's storing all the blockchain information right here in this app data folder. So that way it picks up where it left off and it doesn't have to sync the whole history of the blockchain every single time it restarts the app. And then, or generates from the Genesis file if the node started for the first time. So basically, if there's no data there, it will try to start it from scratch. But otherwise, it'll pick up where it left off with the app data folder. Here's an example with that simulation application. Okay. So we got, yeah, we'll dig into this stuff later once we have more stuff defined. I don't want to. This is long here. I don't think it'd be valuable at this point in time for us just to read through it and understand every single line by line. I think it'll make more sense if we just keep reading. So the init chainer is a function that initializes the state of an application from a Genesis file. So, for example, token balances of a Genesis account. It is called when the application receives the init chain, or receives the init chain message from the Tendermint engine, which happens when the node is started at block height 0. So at block height 0 is the Genesis block. The application must set the init chainer in its constructor via the set init chainer method. So we just got a program where it starts. Makes sense. In general, the init chainer is mostly composed of the init genesis function of each of the application's modules. This is done by calling the init genesis function of each of module manager, which in turn will call the init genesis function of each of the modules it contains. Note the order in which the modules init genesis functions must be called has to be set in the module manager using the module manager's set order init genesis method. This is done in the application's constructor. And the set order init genesis has to be called before set init chainer. This is great information here. So it's saying that so in the module manager, we have init genesis, right? And we call init genesis that will initialize the blockchain. And then init genesis has to be, my nose itched. It has to be set in the module manager. So we go in the module manager and set init genesis using the module manager's set order init genesis method. This is done in the application's constructor. Okay. I'm sure once we have our hands on the app, it'll kind of come together there. Okay. Just seeing how far we want to go. All right, cool. So begin blocker and end blocker, Cosmos SDK offers developers the possibility to implement automatic execution of code as part of their application. This is implemented through two functions, should be plural, two functions called begin blocker and end blocker. They are called when the application receives, respectively, the begin block and end block message of the Tendermint engine, which happens at the beginning and at the end of each block. The application must set the begin blocker and end blocker in its constructor via the set begin blocker and set end blocker methods. Okay, so constructor is just a function. All right. So we're just declaring like app creator as a function, and then we're throwing that inside of it. So if that doesn't make sense, we'll explain it as we get deeper. In general, the begin blocker and end blocker functions are mostly composed composed of the begin block and end block functions of each of the application's modules. This is done by calling begin and end, This is done by calling the begin block and end block functions of the module manager, which in turn will call the begin block and end block functions of each of the modules it contains. Note that the order in which modules begin block and end block functions must be called has to be set in the module manager using, they gotta be in order. As a side note, it's important to remember the application-specific blockchains are deterministic. Developers must be careful not to introduce non-determinism in begin blocker or end blocker, and must also be careful not to make them too computationally expensive, as gas does not constrain the cost of begin blocker and end blocker execution. See an example of begin blocker, end blocker, blocker. That's great. See an example of begin blocker and end blocker functions of the SimApp. So we'll make sense of that later. So register codec. The encoding config structure is the last important part of the app.go file. The goal of the structure is to define the codecs that will be used throughout the app. Here are descriptions of what each of the 4 fields means. So interface registry is the interface registry is used by the protobuf codec to handle interfaces that are encoded and decoded, we say unpacked, using google.protobuf.any. Any could be thought as a structure that contains type URL, like the name of a concrete type implementing the interface and a value. It's encoded bytes. Interface registry provides a mechanism for registering interfaces and implementations that can be safely unpacked from any. Each of the application's modules implement the register interfaces methods that can be used to register the module's own interfaces and implementations. You can read more about any in ADR 19. So ADR 19. I don't want to read that right now. We'll get to that later. Go to more detail. The Cosmos SDK uses an implementation of the protobuf specification called GoGo protobuf. By default, the GoGo protobuf implementation of any uses global type registrations to decode values packed in any into concrete Go types. This introduces a vulnerability where any malicious module in the dependency tree could register a type with the global protobuf registry and caused it to be loaded and unmarshaled by a transaction that referenced it in the type URL field for information. Okay, so there's basically a blockchain exploit that could happen here if we don't have our details right. So codec, the default codec used through the Cosmos SDK, it is composed of a binary codec used to encode and decode state and a JSON codec used to output data to the users. For example, in the CLI by default, the SDK uses protobuf as a codec. Cool. I got crunchy back from my chair sitting, apparently. Tech or transaction config. So transaction config or TX config defines an interface a client can utilize to generate an application-defined concrete transaction type. Currently, the SDK handles 2 transaction types, sign mode direct, which uses protobuf binary as over-the-wire encoding, and sign mode legacy amino JSON, which depends on amino. And we can read more about transactions here, which let's take a quick look. So that's in core concept. So we'll get to that later down the line here. We're here. We'll get to that when we're right there. So Amino, some legacy parts of the Cosmos SDK still use Amino for backwards compatibility. Each module exposes a register legacy Amino method to register the module's specific type with Amino. This Amino codec should not be used by app developers anymore and will be removed in future releases. So we've read that before. Cosmos SDK exposes a make test encoding config function used to create an encoding config for the app constructor, which is new app. It uses protobuf as a default codec. So note, this function is deprecated and should only be used to create an app or in tests. So don't use this anymore. See an example, make test encoding config from SimApp. Interesting. All right. So, got a lot more to go. So we'll pick this up in our next session. Don't want to overwhelm anybody. We made it halfway through the anatomy. So we'll get into modules, application module interface, message services, gRPC query services, keeper, command line. This is where it gets juicy. Command line, gRPC services, and REST interfaces. That's where we can actually talk to it and develop some apps that can do things we care about. The application interface and dependencies in the makefile. So it looks like it gets pretty hands-on as we continue here. So the rest of it is very, very contextually relevant, but I don't think we have to get hung up on it. So I know as we go, kind of a fog sets in and things become, kind of less clear. You end up having, more questions than answers as you keep digging. So we're just kind of at that phase where we're asking questions, we're being exposed to new terms and concepts. And I said this in episode 1, and I'll say this here in episode 2 as we conclude. You got to be patient with yourself. You got to go at whatever quality pace your brain can actually comprehend these concepts, and read it a few times, check out the references, see if you can word it another way, and using those tools, we can validate our understanding is correct. And if it is correct, then we have a working understanding of this application. We can actually answer some more complex questions with our general, understanding of this application now, because, we kind of get it, right? Like we know the different pieces. We know when someone uses the application, like, where does data go? Where does it keep going? Until it's on the block. So if I send you money on this blockchain, how did that happen? I used an app probably. What did the app actually do? I now understand some of that. So if I want to change, how my applications are functioning and add features and security checks, stuff like that, we can, because we understand the different moving pieces. So I say this as an encouragement. Be patient with yourself. Stay focused, stay driven, remove distractions when we're studying, use the bathroom, make sure you get a good drink, so you don't got to get up from your desk. Make sure you ate something before you sit down to study, so you're not looking for snacks and whatever. Not getting Cheeto dust on your keyboard. Shameful. Don't do that. And then, just commit 45 minutes to an hour of just really focused study. Take a break, come back, because you will get, this isn't true for everybody, but most people, you will get diminishing returns if you just keep driving without taking breaks. Like, be intense, but be intense with a pace, right? Be intense for 45 minutes to an hour. And kind of set a clock and do that, and then take your 15 minutes or whatever and get up and stretch, go get some fresh air, use the bathroom, get a drink, say hi to your family, pet your doggy, do that kind of stuff. And then if you're continuing your work, get back to your study and throw in another 45 to an hour. And then keep that pace. Just take a break. You'll find that you can sustain a much longer focus throughout your day if you pace yourself there. So this is just some life advice, some study advice that I found just in my life and work. So I hope that's useful to you. I'll go ahead and leave us off there, but from the bottom of my heart, love this community. I hope this is useful to some people, and if it's not, then at very least it helped me to go through this exercise to study talking with you. So thank you, be well, and until next episode, I'm the Data Lord. Thank you for joining me for a study session, Cosmo, episode 2. Peace.